안녕하십니까?
Greetings. I would like to greet everybody watching the video journal of Korean Academy of Endodontics. I am Dr. Cho SY, Planning Director at the Academy. The new video journal is about KAE trying to communicate with its members and to provide meaningful information. Rather than reading studies in a difficult manner, I wanted to provide a brief explanation so you can understand more easily. I'm going to choose from studies that I've conducted in the past 5 years, and the author is going to talk about the study, and I hope you get the gist of the study. I'm going to talk about how occlusal force changes depending on the treatment modality of cracked tooth. How do you treat cracked tooth? I use the bonding ability of resin, and I used to enjoy resin restoration. In those cases, conditions would disappear and it'll be maintained well, or it can become worse and it may require endodontic treatment. I want to talk about how the tooth responds to the occlusal force after cracked tooth was treated. I wanted to see how occlusal force is delivered to the internal structure of the tooth and how much stress is focused on the area where there was a crack. It is clinically impossible to apply different treatment modalities on a cracked tooth, so I used a finite element method, which is a type of computer method. First, I modeled the lower molar and gave crack. There were 4 different types of treatment: inlay, onlay, and crown. And for inlay-onlay type, direct resin and indirect ceramic restorations were provided. Today, due to time constraint, I'm going to talk about onlay direct resin restoration case and onlay indirect ceramic restoration case, as well as crown restoration and crown restoration after resin restoration. I'm going to focus on these 4. The occlusal force is going to be expressed in ball-shaped form. 1,000 Newton centimeter of occlusal force is going to be applied. How is occlusal force distributed in the tooth? It is expressed in the color. The red is high stress, blue is low stress. I wanted to see how occlusal force is distributed across the occlusal surface and how stress was transferred to the inferior portion of the tooth. I also measured the stress at the tip of the crack. This reflects the amount of force that extends the crack, so you'll be able to know whether the crack is going to progress. Different types of physical property was provided to different restorations. I wanted to look at elastic modulus in particular. This not only helps us in understanding the study results, but if you refer to it, it'll be very meaningful when you provide the restorative treatment. Elastic modulus reflects the level of elasticity, and the higher it gets more stiff, and lower it gets, it becomes more elastic and soft. The enamel is 84,000 and the dentin is 14,700 and resin was 9,800, so 1/9 of enamel and 2/3 of dentin. As for ceramic and gold, they were each 94,000 and 85,000, and they were similar with enamel in terms of elastic modulus. In other words, resin is softer than dentin, and ceramic and gold are almost as hard as enamel. Let's look at the results. Resin, on the occlusal surface, the stress is concentrated in a small area and a lot of stress is delivered to the inferior portion of the restoration. In the case of ceramic, on the occlusal surface, it is distributed more widely, and you can see the red bit around the crack line and proximal box on the restoration. A more stronger force is delivered. In other words, in the case of resin with less elastic modulus, because it is deformed Because of occlusal force, it absorbs the stress and it reduces stress delivered to the inferior area. But in the case of ceramic with big elastic modulus, it's hard, so it is not deformed, and the stress is delivered to the inferior portion, and stress can be observed in the lower portion. The thickness of the crown in these two restorations, they are quite thin and it is wide across the occlusal surface. The stress is transferred along the stiff lateral side of the crown. Therefore, it is less delivered to the dentin below, which is more elastic. The tip of the crack, in other words, left side of the proximal box, this is where the tooth is most weakest. If you look at the stress in resin and the coreless crown, the first one and third one, it is 40 to 39 megapascal, so it's quite high. In the case of second and fourth ceramic and crown with resin core, they are 23 and 22 megapascals, so relatively low. In other words, in the case of resin with low elastic modulus, the material absorbs stress and reduces stress delivered below, but at the same time, it also lacks the ability to prevent the widening of the crack, and a lot of stress is focused on the tip of the crack. On the other hand, ceramic is stiff, so it does not really absorb stress, and a lot of it is delivered below, but it is not elastic, so it prevents widening of the crack, and the stress on the tip of the crack is low. As for the crown, the stiff restoration is formed wide across the occlusal surface and the lateral surface, and stress is transferred that way. Not a lot of stress is delivered towards the center dentin. Unless you do resin core because of the vulnerable structure, the stress can be concentrated on the tip of the crack, and the crack can additionally widen. Therefore, a resin core is a must. I would like to move on to conclusion. Resin has low elastic modulus and absorbs the stress and delivers less stress. However, it does not stop progression of crack. In the case of ceramic and gold, it does not absorb stress and it is delivered to below, but it can contain the crack. Ceramic restoration or gold crown accompanied by resin core, it can be favorable to stop progression of the crack. Resin restoration can be useful as well. However, in the case, you need to minimize crack line as much as possible. Did you enjoy the video journal? I hope it had the effect of reading one study. Thank you.